I'm Tessa Kelly. I'm an engineer at No Red Ink and a tech startup helping teachers teach grammar and writing. I've been writing and working with production Elm code for a little over 2 years. I've got my Twitter handle up on this slide. Please feel free to tweet kind things at me. Today I'm going to be talking about web accessibility with Elm. First off, what is accessibility? Accessibility is a long word and a big topic. In general, it refers to ease of entry or of use. In some contexts, accessibility might refer more to an ease of acquisition of knowledge. For instance, this presentation so far is an example of inaccessibility. Visually, it's fairly difficult for me to distinguish the background color of the slide from the text of the slide as I look at my laptop screen. For you on the audience looking at the projector screen, I imagine it's even harder to read and to follow along. While you can access some of the content of the presentation, you might have wanted to tweet, "I can't read your slides," at me, and not been able to since I didn't share my Twitter handle orally. So why is this slide hard to read? The font isn't crazy tiny, the colors are bright and vibrant, classic Elm colors. This slide is hard to read because the contrast and luminance between the two colors is too low. It's 1.89. Non-giant text should generally have a minimum contrast of 4.5 to 1, with higher contrast options available for visually impaired users. All right, so let's try this again. Hello, I'm Tessa Kelly. I'm an engineer at No Red Ink and a tech startup helping teachers teach grammar and writing. Still been writing and working with production Elm code for a little over 2 years. I've still got my Twitter handle up on this slide, T_Kelly9. Now it's hopefully a little bit more readable. And I'm still going to be talking about web accessibility with Elm. If you'd like to follow along with these slides on your own machine, please go to slides.com/tessak/elm/live. All right. So what is accessibility? It means having slides that are legible from the front of the room and from the back of the room. Having accessible content means that people with various means of interacting with your material can use and understand it. Today, I'm going to be talking about specifications, about building and evolving an Elm library, and about coding accessibly. My hope is that at the end of this talk, you'll feel excited about building accessible applications and empowered to do so. As web developers, we choose not to be accessible by some means all the time. We say, Internet Explorer 6 users won't be able to use our site, or people with JavaScript disabled won't be able to use our site. But when we're choosing to support a given browser, we test that our code works successfully in that browser. Sure, maybe some portions of the experience are degraded in this browser or that, but the core content is available and workable. When we choose not to follow best accessibility practices, the impact on the user is not the same as degraded styles or mild bugginess. When not writing code with accessibility in mind, the impact is that prospective users can't use our site at all. Consider again this presentation. We fixed the color contrast on the slide, which increases the number of people who will be able to follow along with the slide content. But if the video recording of this talk is posted online without captions, those who have a hard time processing oral information or with auditory impairments will not be able to follow. This presentation would not be useful at all. It's been a long time since I changed the slide, and I've said a lot of words. Thank you again for doing the live captioning. That's awesome, Futureize. OK, so we want, in essence, to add captions to our dynamic content. We want to use high contrast colors. We want to make choices that will enable user agents to provide our content to those trying to use it. So let's discuss the accessibility principles that we can use to drive how we make these choices. At a high level, we're talking about both design and implementation. How do we design for users with varied needs? The second set of web content accessibility guidelines recommends 4 key principles. The first of these principles is perceivability. Make different color schemes available to match the needs of populations with varied vision. Make content available in text form. Provide captions and descriptions. The next principle is operability. Make sure your application is fully navigable and usable via the keyboard. Lay out your application predictably, and signpost what various sections are for. Don't assume that your users read time-based materials at the same rate as you. Don't rapidly flash content at your users. Understandability asks that developers adhere to normal and expected web behavior. Be predictable. Use buttons that behave like buttons and text inputs that behave like text inputs. For forms, when a user enters something invalid, tell them what's wrong using words. Understandability often also means mirroring familiar behavior from the desktop experience, say how an alert dialog works. Finally, robustness. Essentially, try to be as compatible as possible with the HTML specification and the ARIA specification. Write beautiful and valid code. All right. Notice that all of these principles make the web better for everyone. Who doesn't want robust, keyboard and user-friendly, easily navigable sites with varied ways to consume and interact with content? Now that we've covered some high-level principles, let's dive into some detail. The World Wide Web Consortium, the old W3C, puts out a new HTML specification that various browsers, various user agents try their best to adhere to. The W3C also puts out a technical specification for accessibility called WAIARIA, short for Web Accessibility Initiative, Accessible Rich Internet Applications. Various assistive technologies try to match this standard. Developers aim to use this spec in the same way that they use HTML. Confusingly, sometimes the HTML spec and the ARIA spec overlap each other or outpace each other, and this can make ARIA scarier than it should. Generally speaking, the ARIA spec describes roles, states, and properties that may or may not be implicitly defined or set on a corresponding HTML element. If you have the option to use a native element, do so. The spec tends to distinguish between roles, which describe the structural or semantic purpose of an HTML node, and the states and property that make it meaningful. Know, though, that the roles that the spec defines inherit from each other. Roles have superclass roles and subclass roles, and abstract roles, which are only for inheriting from and which you're not supposed to use directly. All of which is to say, it can be challenging to understand one piece of the spec without needing to understand a lot. So let's move through some attempts to provide view helpers to make it a bit easier. I'd like to take another minute to give everyone a chance to go to this link one more time if you want to view the live slides on your machine, because there will be actual code, and some of it may be small. We'll see. All right. So building an Elm accessibility library. The first version of the Elm accessibility library was called Elm HTML accessibility. So an initial and fairly easy to identify problem here is that when you're speaking aloud, you experience a moment of indecision over whether to say A11Y or accessibility, and then you panic, or I panic, and say ally but with ones, and then everybody's confused. So the newest version of the accessibility library is called Accessible HTML. We'll get more into what that library looks like as we go, but for now, note that it was way easier to understand what I said than accessibility spelled A11Y. So initially with this library, I tried to do as straight a translation of ARIA roles, states, and properties into Elm as possible, while leveraging some of Elm's nice design patterns. These patterns included matching the module names of the accessibility library to those of the HTML library. So the Elm-lang HTML library exposes the HTML module and the HTML attributes module. In keeping with this, Elm HTML accessibility exposed HTML accessibility and HTML attributes accessibility. Again, spelled A11Y. I also dropped a very useful pattern from the Elm-lang HTML library. Here's a question to elucidate the niceness of this pattern. What's the type signature for the var HTML tag? Follow-up question, did you know that var existed as an HTML tag before I asked that question? So many of us didn't know that var was an HTML tag, but still knew that the Elm implementation would be a function that takes a list of attributes and a list of HTML children and returns HTML. So in HTML, image tags and BR tags don't have children, but it's still super, super nice to have a consistent API when working with images and break tags in Elm. So all of that said about how nice this is, accessible HTML and Elm HTML accessibility dropped the consistent API in order to require that images have alternate text. So as you can see on the slide, the image helper takes a string, the alternate text, and a list of attributes and returns HTML. But Tessa, you say, it looks like image has alt text required as an argument and decorative image doesn't. So decorative images don't have alternate text, right? Great question. Actually, a decorative image sets the alt text to be empty string. Assistive technologies will read the file name if there's no alt text. So you need to be explicit when you don't want alt text. So say you use a cache invalidation scheme involving hashes in your file names. Better make sure you have some explicit empty string alt text on decorative images if you don't want to overwhelm users with very long file names, like logo_37, whatever. OK, so on to the next pattern. Here, I decided to follow a pattern that I've seen across the Elm community. Often, Elm developers prefer to have multiple related functions than to have a single function that requires other developers to understand additional details about that function's internals to use it. That is, rather than have a single autocomplete helper that a developer can pass an argument specifying inline, both, or list, have three simpler functions: autocomplete inline, autocomplete list, and autocomplete both. While we're discussing autocompletion, these attributes allow you to communicate that you are providing a list of autocomplete options or an inline autocomplete recommendation on a search input. To see what autocomplete both looks like, type something you've written before in Chrome's URL bar. You'll see options going across and options going down. So there were other patterns that failed and other patterns that worked in this initial version of the library. But let's move on to the newest and brightest iteration, accessible HTML. So that's the module name, or not the module name, sorry, the library name. All right, so the original module names in Elm HTML accessibility were bad. They were hard to read, and for whatever reason, it was very difficult to remember whether the accessibility part came before or after attributes. So the new version of the library scopes the helpers, making the library easier to search and to navigate. So accessibility contains view functions. Accessibility ARIA contains ARIA attributes you may have seen before, including those that associate elements in the HTML with each other outside the node tree hierarchy. Think controls, labeled by, described by. Accessibility key has helpers for the keyboard events that your accessible widgets require. Right arrow, left arrow, enter, spacebar, escape. Accessibility landmark contains landmark roles that make the layout of your site apparent. The only landmark role that you aren't already using implicitly when you use HTML structural elements like section, header, footer, aside is search. So search is likely all that you'll use from this module. Accessibility Live has helpers for communicating that a section of the page is changing or will change or has changed, and would you please notify the user when you get a moment. Accessibility Role can help you make a div into a menu or modal or anything else by describing the div's purpose. And finally, Accessibility Style. Accessibility Style currently just has one helper in it for hiding content from screen viewers but keeping it for screen readers. Of course, it's better to have users on your site have access to the same content. But on occasion, this might be of use if your design calls for, say, unlabeled inputs whose purpose is communicated via placeholder. You should still include a meaningful label, and you can if it's hidden. The other big change in the accessible HTML library, and this is one that I'm really excited about, is that the library actively discourages adding event listeners to non-natively interactable elements. Notice that the type annotation on image has changed from taking a list of generalized HTML attributes to taking a list of attribute nevers. This means that if you try to use onClick on an accessibility image, you're going to have compilation errors. And that's true not only for images. Accessible HTML provides an alias for every view function in Elm-lang HTML. Most of these aliases are restricted to prohibit event listening, which means no clickable divs. So if that last batch of design decisions seemed suspiciously better than the batch before, is because I consulted with Evan, and he had all the right questions and all the best ideas, as is typical, just typical. All right, so now that we've got a sense of the landscape, let's get cracking on the accessible widget front. So recall POUR, our acronym for Accessible Design Principles. Any widget that we make should be perceivable, operable, understandable, and robust. Consider a dynamic element like a tooltip. If people didn't need tooltips to understand how your application works, probably you wouldn't have them in your application. So if you want for all your users to understand your application, you need your tooltips to be available to all your users. Now, there are tons of ways of making tooltips, including some really cool CSS options. The particular implementation that we're working with is meant to be the naive tooltip. And it's a naive tooltip that isn't much use to many of our users. The demo GIF here is of a div with rainbow radial gradient styling, kind of just for fun. On hover, this rainbow div shows an absolutely positioned yellow tooltip with nonsensical content. Then in terms of code, we've got our div and an if-else expression determining whether to render the tooltip or not. Notice the on-mouse enter and on-mouse exit event listeners. Perhaps obvious to point out, but these require our users to be using a mouse or at least a cursor. Also notice that the tooltip isn't described as a tooltip, apart from in a class name that users won't have access to. Essentially, this tooltip is just a div that's sometimes rendered and sometimes not. Let's improve this. Let's specify that this is a tooltip using the tooltip role. Next, let's give the tooltip an ID so that we can say that the rainbow div is described by the tooltip. Now it's clear that there's a relationship between the div with the radial rainbow gradient and the tooltip itself. So let's take a step back from the tooltip to think about roles more broadly. There are many widget roles that can help make your content perceivable. But some of these widget roles are no longer necessary to explicitly specify with the advent of HTML5. For instance, the role progress bar helps communicate with users about ongoing tasks, like waiting for a response to an AJAX request. Here is a sketch of an implementation of a progress bar. We've added the role progress bar to a div and set a min value and max value in the current value. We've also thrown on some styling to make it look remotely like a progress bar. Although, as you may see coming, it's a pretty ugly one. But we also have a progress tag available, and that's a better option. Using the progress tag, we set the current value and the max value. We need to disambiguate max here because of the max function in basics. And that's it. Comparing the outputs, one of these was harder to construct and still doesn't look as nice as the other. In fairness, the output of the role-based progress bar is more likely to be visually consistent across browsers than the output of the progress element. But using the HTML progress element means that users will have a more consistent experience across the applications and websites that they visit in their chosen user agent. Is it more valuable for an application to have perfectly consistent styling across browsers, or for application users to have immediate familiarity with the widgets they're encountering? All right, back to our tooltip. So now we're on to operability, the O in POUR. Right now, our tooltip still requires that a user hover over it in order for it to launch. So let's get some keyboard behavior going so that our tooltip is operable for our users. First off, we want the element we're describing with our tooltip to be tabbable. This will add the element to the tab order of the page and allow it to receive focus. Next, we want the tooltip to open when focus is on that element and close on blur. We can also have our tooltip open on space and close on escape. If we want, there's a keyboard shortcuts property we can use to specify key combinations as well, but it's generally better to use familiar key combinations like space and escape. All right, and there's our operable tooltip. The focus behavior is going to be a little bit difficult to see since I didn't restyle it from the default But notice that the tooltip opens and closes when the mouse isn't actually hovering over the div. So to understandability. Having this small widget be operable is helpful. But remember that operability means that our users can navigate our application in general at a high level too. Users should know what different sections of the site are for, and should be able to go to the sections they are interested in. Landmark rules help with this, but again, if you're using HTML5, you probably won't need any of these rules apart from search. But you will need to actually use those HTML structural elements. So sections aside, headings of appropriate levels, that means H1, H2, H3 in order, headers, footers, etc. Another key piece to understandability is having clear focus behavior. For keyboard users, knowing exactly which element they're interacting with is very important. This means that getting rid of focus styling is bad for users. Imagine eliminating the focus styling on our tooltip widget and then trying to open it in the context of a fairly complex application. It's not going to be easy, especially on an unfamiliar site. If you, as a person with a great deal of knowledge and context about your application, can't navigate using only the keyboard, neither can your users. HTML5 elements are your friends here. It's far harder to duplicate existing HTML keyboard behavior on a div than it is to use the appropriate HTML element. For instance, you should be able to change selections and cycle through a group of radio inputs with your right and left arrow keys. That's default behavior. But it's not quite a trivial ask when trying to build from scratch. There's also the question of tab order. We have additional desired tab behavior on top of any in-widget keyboard behavior we might need. Notice that up, down, left, and right navigate us within our radio button field set, but tab takes us out of it, leaving the last radio to have focus selected. The accessible HTML library offers the Boolean-based tabable rather than tab index in order to prevent unexpected tab order. Tabable is the property we used in order to allow our rainbow div from before to take focus. If you've run into z-index confusion, you'll be familiar with the kind of trouble you can get into with tab index. Just for fun, let's take a look at how thoroughly we can bounce around and confuse ourselves. So here's some code that adds tab indices to a list of divs. The first and last div have tab index 1. The second and penultimate divs have tab index 2, and so on. Most left to right language reading users will assume a tab sequence that looks like this. Left to right, top to bottom. But we've very easily just created a tab sequence that instead goes out to in. Now suppose you want to add additional elements to this tab sequence. It won't be as straightforward as it would have been if we hadn't changed tab index to positive numbers. Another way to say this, people who navigate primarily with the mouse will go through this flow entirely differently than those who navigate primarily with the keyboard. Creating and supporting two solid and well-designed user flows is harder than creating and supporting one. One final note on managing focus before we move on. Consider the mighty modal. A naive modal might just pop over whatever content is on the page. A slightly less naive modal might have a backdrop of some kind, preventing users from clicking through and interacting with elements behind it. But that doesn't address every means of interaction. In this example, the button that launches the modal appears before a number of links. Not really a crazy situation to have. We focus on the button and activate it, launching the modal. We hit tab, and now we're under the backdrop on random links that aren't relevant to the content that we've asked to interact with. We can still get to the modal content, but it takes a while. And in a less contrived example, it's probably going to be confusing in addition to slow. When a modal launches, focus should be on the first focusable element in that modal. Tabbing should be a clear and convenient strategy for page navigation, not an endless trudge to catch up with UI state changes. All right. Now that we've talked about tabbing behavior, let's talk tabs. So here again, we have perceivable, operable, understandable, and robust across the top in kind of a pretend tab widget. So to start off with, perceivable. There are 3 sections to a tab widget. There's a container with a list of tabs. So imagine that there's a div stretching across the top here containing the perceivable, operable, understandable, and robust items. Then there's the tabs themselves. So here, perceivable is the selected tab. Then there's the panel that shows for a given tab. So ARIA provides roles for each of these items, parts of a tab component. Their names more or less describe their purpose. Tab is the bit you select to switch to a different panel. Tab list is the list of tabs, and tab panel is the contents for a tab. These helpers all come from accessibility.role. Operable. In order for our tab component to be operable, we'll want to be able to click the tabs to have them do something. We'll also want them to be tabbable to support our keyboard actions. And then on top of that, we'll actually want our keyboard actions. What that means is that we need tabbable, on-key down, and decoder helpers for the keys we're interested in. For now, let's say we want to use only the left and right arrows to operate our components. Alternatively and additionally, tab components sometimes support tab and tab shift, focusing through the elements with a space or enter to select a tab. Which pattern you choose may depend on broader page behavior. Say you have a single page app, and changing tabs triggers an AJAX request. A user trying to get from the first tab to the, a user trying to get to the 4th tab from the first tab won't intend to trigger data loads on tab 2 and tab 3. But that's what will happen when the user hits their right arrow key 3 times on the way over to tab 4, if you're following the left and right arrow strategy. Understandable. Which tab controls which panel? What's the tab say about the current panel? Which tab is selected? All of these questions are answered visually through styling. Here, the selected tab is white. The unselected tabs are gray. The selected tab is connected to its tab panel by the absence of the border below the tab, making it appear that the tab and the tab panel are connected, are a single item. But we also need to establish these relationships programmatically. Here, we can use controls and labeled by to establish the relationships. Both functions take the ID of the corresponding element. We also have selected for setting whether a tab is selected or not. Before considering the robustness of this approach, let's give putting all of these pieces together a shot. Here are our necessary imports. It's not a short list, but it should all be familiar at this point. So we've got accessibility. We've got accessibility.aria with our controls and labeled by. We have our keyboard helpers. We have our roles for tab, tab list, and tab panel. Widget, we haven't really worked with much, but that's where selected and other state properties live. And then we have attributes. We need that ID. And events, because we also want to support mouse users. And this is the starting point for our first tab and first panel. Notice that each has an ID. The tab controls the tab panel. And the panel is labeled by the tab. We've also added roles, and the tab is tabbable. Building up our tab list, we've added 2 more tab panel pairs and the tab list role. Note that the tabs are children of the tab list, but the panels are not. So that gets us a basically working tab widget. At this point, what's left is to add click and keyboard listeners and some corresponding logic. There's also another facet to perceivability that we haven't talked about explicitly: hiding content. We don't want to show every panel as we are currently and have the user try to figure out which panel is the relevant one. That kind of defeats the whole purpose of tabs. So we'll want to use the hidden property on our irrelevant tab panels in order to keep our relevant tab panel perceivable. Before we do that, though, let's return to the idea of robustness. So we used a number of properties already to get this far, and it is visually kind of difficult to parse if we have done so correctly or not. Fortunately for us, accessible HTML is full of helpers. Specifically, we have tab list, a function that creates an HTML element with a tab list role. We have tab, a function that creates an HTML element that has the tab role, is tabbable, and accepts event listeners. Notice that there's no never on tab here. And finally, we have tab panel, which sets the role to be tab panel. So these are all from the accessibility module. This lets us use ARIA roles without really being aware that we're doing it, which is kind of similar to how the HTML spec works. Remember what our code looks like. We have many roles on many elements, but they're buried in lists of attributes. Using the main tab panel, and tab list helpers, we can clean up our code, making it easier to understand and easier to work with. This version of the code emphasizes the purpose of each element. Rather than having divs, which are incidentally used for some role, it's visually clear that tab list, and tab panel have meaning. All right, so on to tab selection. I'm leaving out a fair bit of detail here, in particular data modeling considerations. A truly robust implementation would probably use a circular linked list or a similar structure in order to model which tab you're actually on. Notice that we now have a view tab function rather than exhaustively listing each tab. We're setting selected to be true when the tab is current. We're also using on-click and on-key down together. On the panel side, we hide irrelevant panels. So that's our hidden for the not current one. So let's take a peek at how this looks so far. I've added a border and background color to the selected tab in order to make this easier to follow. Although I'll be the first to admit that this is not yet looking like tab behavior in any way, but functionally. So we went through this exercise of building a tab widget with various static pictures of tabs in the background. Now we've got a tab widget that doesn't much look like a tab widget. So the question, which of the two is truly more tabby? All right, so we've covered a lot of material in a short amount of time. Some of it was high level, like WCAG's perceivable, operable, understandable, and robust guidelines. Some of the material was super specific, like how image alt text is interpreted. I began by talking about color contrast, and I expect some of you began the presentation with a feeling of frustration as a result. We talked about design decisions in accessible HTML and the motivations behind those decisions. And then we also whipped up a couple of widgets. On the other hand, there's a lot we didn't cover. We didn't discuss the accessible HTML, checkbox, radio, and input text helpers that emphasize the type of input you're working with and help you to include every necessary property. We didn't talk about label before and label after helpers that simplify labeling your inputs. We didn't do more than mention live regions by way of the accessibility live module. And we didn't discuss how some ARIA roles have implicit live region properties. We covered only a few of the myriad of widgets that a developer is likely to be asked to build, and probably that you have built already. We also skimmed past areas of improvement for the accessible HTML library. At this point, not every role in the accessibility library has corresponding view helpers like tab, tab list, and tab panel. Not every input type has a helper defined for creating inputs of that type. Documentation is mostly good, but is certainly not without holes. But all that being said, I believe that with a decision to use this library or one like it, we as the community can work ahead of the HTML spec. We can make the conscious decision to support our users. We can stop ourselves from making clickable divs instead of buttons, or adding images without alt text. We can pour perceivable, operable, understandable, and robust code into the interwebs for people to use. So I would like to encourage you to take this as an invitation to contribute to the library. If you see mistakes, missing or confusing documentation, omissions, potential extensions to the existing functionality or anything else, jump on in. In this talk, I pointed out places where the library was bad and then got better. I hope to have many more examples of massive improvement this time next year, too. I'd also like to encourage you to use it if any of this looks cool or helpful. And finally, I'd like to end with some broader comments. The core design philosophies of Elm all center around its being open, easy to use, nice to use. The Elm community puts emphasis on being open, on getting people the information or aid they need, and on being empathetic. I know that we as a community can and do write code that reflects these values, and I hope that we can inspire other code communities in turn. As always, I'm looking forward to seeing what amazing work the Elm community does next. Thank you.